Hi, this is a review of some of the main essential learning outcomes of this course. So the first one, it says to find the missing side of each triangle. So when we look at the triangles, hopefully we notice that they are right triangles. And whenever you know two sides of a right triangle, you can find the third by using the good old Pythagorean theorem, which is c squared equals a squared plus b squared. Important things to remember are the C is always the hypotenuse, and that is across from the right angle. So this is your C. So we're going to substitute that in. And the A and the B can be either number, either of the legs. And then after that, it's a matter of solving for x. So on the right side, we can square both of those numbers. So in my calculator, I will type in 11 to the second plus 12.3 to the second, and that gives me 272.29. And then to solve it, we will take the square root of both sides. So x is equal to the square root of, oops, I hit the wrong button here, the square root of 272.29, which is 16.5. So that's my answer. Remember, the hypotenuse is always the longest side of the triangle, so you can kind of make sure your answer is longer than the other two sides, and then that would be feet. All right, the next one, again, we have a right triangle. We know 2 out of 3 sides, so we can use the Pythagorean theorem. So the C is always across from the right angle. So in this case, the C is 13.7. So what we're going to do first is square the numbers. So 13.7 squared is 187.7 if I round it. And 4.7 squared is 22.1. Now we are solving for x squared, so we need to get x squared by itself. I should say we're solving for x. So you have x squared is equal to, we subtract, we get 165.6. And then lastly, we'll take the square root of both sides. So x equals the square root of 165.6, which is 12.9. Okay, in the next example, it says that the measure of angle HCD, so from H to C to D, that is 33. My pen seems like it's a little off. And then angle BCH is 88. And then it says find the measure of angle BCD, which is the whole thing. So if you'll recall, when we add two angles that are adjacent to each other, which means next to, we can use the angle addition postulate, which means we can add those angles together. So the measure of angle BCD is equal to 121. In the next example, we need to label. So it says the measure of angle STU, so that's the whole thing, is 4x plus 18. The measure of angle HTU is 36. And the measure of angle STH is x plus 12. So that's this angle right here. So angle addition says part plus part, the little angle plus the little angle, part plus part equals the whole angle. So x plus 12 plus 36, so the two small angles equal the whole angle 4x plus 18. So we have an equation. So draw the line here. And remember, we first want to combine like terms. So we have 1x, and then 12 plus 36 is 48. And on this side, we have 4x plus 18. Now we want to get the x's on the same side. So I think we'll start by subtracting 1x from this side. And if we subtract 1x from the left, we subtract 1x from the right. So 48 is equal to 3x plus 18. So go ahead and write that down. Now we want the x to be by itself, the 3x term. So we are going to subtract 18 from the right side because that will cancel. But then we have to subtract 18 from the left side. So you have 3x equals 30. And now you have 3 times x. The opposite of 3 times x is 3 divided by 3. So the 3's cancel there, so you have 1x equals 10. So that's your answer. All right, in number 5, it says find the value of x. So what we want to do is think about the angles that are represented here. When they're across from each other like that, remember they're called vertical angles. And we learned that those are congruent, which means they are equal in measure. So you set them equal to each other, and then you divide to solve. So x will equal 13. The next set of angles, when we look at those angles, we see that they add up to 90, and the term for that would be complementary. They are complementary because their sum is 90. So to write an equation, we can say x plus 10 plus 60 is equal to 90. Combine like terms, we have an equation, so x plus 70 equals 90. Now we want to get the x term by itself. The opposite of adding 70 is subtracting 70, so it cancels there. And if we subtract from the left, we subtract from the right. So x equals 20 is our final answer. All right, we're talking about angle pairs here when there are parallel lines in these next few problems. So if you will recall, angles that are in the same position to the parallel line, so you have a transversal right here, and to the left of the transversal and above the line is 1 plus 2x. To the left of the transversal and above the second line is 89. Those are called corresponding angles, and they are congruent. So what we do is we set those equal to each other, and then you solve the equation. So again, draw your line, get the x term by itself. So we're going to subtract 1 from both sides. So 2x equals 88. Divide by 2. X equals 44 is my final answer. The next set of angles that we have, they are in between the parallel lines, so they're on the interior, and they are on alternate sides of the transversal, so we call those alternate interior angles. And those are congruent, so we set them equal to each other. And we want to solve. So first get the x term by itself, so we will subtract 3. And then we will divide by 5. So x is equal to 135 divided by 5, which is 27. All right, and then the next set, we have parallel lines again. However, these angles are on the outside of them or the exterior, and alternate exterior angles are also congruent. So 3x plus 1 equals 103. So we'll subtract the 1. So 3x is equal to 102. Divide by 3. So 102 divided by 3, x equals 34. Now you don't have this on your notes, but keep in mind if you have two angles, like let's say that this is 120 and you have another angle, they're both on the same side and on the interior, those are called same side interior or consecutive interior, and these are supplementary. So x plus 120 equals 180. So then to solve that, we would subtract the 120 from each side. So x equals 60. In the next problem, you have a triangle. So if you will recall, the triangle sum theorem says that the sum of the interior angles of a triangle is 180. So all of those angles, if you add them together, so first, we have the equation. We will combine like terms. So on the left side, you have 64 plus 50 plus 70. So you have x plus 184, and that equals 180. And to get x by itself, we would subtract 184 from each side. So this is an interesting problem because x ends up equaling a negative 4. So in order to make these three angles add up to 180, your x would have to be a negative 4. Number 11, it says each figure shows a triangle with one of its angle bisectors. So we have to think about angle bisector, that term. Remember, to bisect means to cut in half. So angle 1 and angle 2 are congruent. So to find the value of x, we set them equal to each other. Angle 1, the measure of it is 3x plus 6. Angle 2, the measure of it is minus 4 plus 4x. So to solve that, we have to get the x's on the same side. It doesn't matter which side you pick. The smaller x term is a 3x, so let's subtract that from this side. And then we'll have to subtract it from the other side also. So you have 6 equals minus 4 plus 1x. Now the opposite of subtracting 4 is adding 4. So we have 1x equals 10. So x's value is 10. Or you could just write x equals 10. All right, let's look at the next one. We're back to triangles here, and it says find the missing side. But now in this example, we do not know two of the sides. We only know one side, and we're looking for the other, but we do know an angle. So this will be a problem that we need to use trig, which is SOHCAHTOA. So write those down just to remind yourself of those letters. So remember what we do to figure out which one we use is we mark the angle and label the side. So across from 23 is the opposite, and across from the right angle is the hypotenuse. So we are going to choose the one that has an O and an H, which would be sine. So the sine of 23 degrees is equal to the opposite over the hypotenuse, which is 19 over x. Now technically, what we could do to solve that is we can cross multiply. So x times the sine of 23 equals 19. So to solve for x, you would have to divide by sine 23 here and divide by sine 23 on the other side. So x would equal 19 divided by sine of 23, which is 48.6. Okay, in the next example, again, we're looking for a side, so we'll mark the angle, and this x is the hypotenuse because it's right across from the right angle, and 11 would be the adjacent. So we're talking about the A and the H, which is cosine. So the cosine of 42 is equal to the adjacent, which is 11, over the hypotenuse, which is x. So again, we will cross multiply. So x times cosine 42 is equal to 11. So then we're going to divide by cosine 42. So x equals 11 divided by cosine 42, which is 14.8. All right, another one. So we have an angle across. We have a 15, which is opposite. The hypotenuse is over here, and so this is the adjacent. So opposite and adjacent, that's going to be tangent. So tangent of 42 is equal to the opposite over the adjacent. Boy, every problem I have in this set has the x on the bottom. So that's an extra step. So x times tangent 42, if we cross multiply, equals 1 times 15. So we divide by tangent 42 on both sides. So 15 divided by tangent 42. So x equals 16.7. All right. One more trig problem. This time, though, it says to find the measure of the angle. So this is the angle. So what we want to do is first label. So this is the hypotenuse. This 34 would be the adjacent. So adjacent and hypotenuse is cosine. So remember though, when we want an angle, we type in angle inverse. So cosine inverse, and it's adjacent over hypotenuse. So second function cosine on the calculator, 34 divided by 57. And we get 53.4 degrees. All right, next problem, we're almost done here. The polygons in each pair are similar. Find the missing side length. So as you can see, this is what we're missing. So I'm going to put an X here. We have the long side on the left and the long side on the left here. So the X is going to correspond to the 12. So I can write X over 12, or X is to 12 as, and we need another set of corresponding sides, and we have to pick where we have two. So we will say X is to 12 as 12 is to 18. So I'm doing right side to right side, bottom to bottom. Once I've done that, set up my proportion. To solve it, I will cross multiply. So 18 times x equals 12 times 12, which is 144. And then I can divide. So 144 divided by 18 is 8. All right, last couple problems here. So we have a triangle, but we have that this angle and this angle are congruent. So remember, if you have two angles congruent, it's an isosceles triangle. These are called base angles. And what we learned is that the sides across are congruent. So if this side's 7, this side's 7. In the next one, again, this is isosceles because you do have two sides congruent. So the base angles are congruent. So we have to do a little figuring here. We know that all the angles add up to 180. So if we do 180 minus 96, you get 84. So the other two angles have to equal 84. So to find out what each of them would be, you would divide by 2. And so 84 divided by 2 is 42. So x will equal 42. All right, that's it for the review. You have a worksheet that is just like the problems on the review, so you can go ahead and start working on those.